Hi and welcome everybody to our asteroid series of videos where we're looking to make a recreation of one of the classic games, Asteroids, but then we're also looking to make it a more modern multiplayer version of that. And if you've been following along with the previous videos, then you'll probably have, hopefully you'll have something like this on your screen here with these moving asteroids. Obviously they need a little bit of work and we need to add in a few extra features to get close to the end game. So hopefully what we're going to do in this video is get the asteroids looking a bit more asteroidy and put in our own ship for us to control. So let's go to the asteroids first of all. Let's see if we can add that jagged edge to it. So hopefully you've still got your code from the previous videos. What I've done, I can't remember if I mentioned this last time, but rather than have a separate terminal window to run the script, I've just simply run it within VS Code here. I'll just show you that actually, just in case you're not familiar. So I'll close this down. So if you've got your VS Code here, what you can do is go up to Terminal, just go to New Terminal, and it brings up this terminal window in the folder, in the root folder of where you're working. So immediately you can start using it from that folder. And the command is quite simple. It's npm run save. I had it on a history, so I just pressed up the up arrow and brought it until it was there. So npm run save, and inside the Vue.js project, that will just bring up our own local server so that we can look at this in our browser here. So you'll notice it's localhost port 8080. And if we go to the browser here, localhost 8080, that's the one we've got, so we can reload that, and we have our server here. So that just means we don't have to have the separate terminal window if you don't want, but either is good. It's up to you. Okay, so we'll just minimize that down. I'm going to try and utilize the zoom feature a bit more as well, just to make in case anything isn't obvious. We'll see how that goes. Okay, so let's make these asteroids a little bit more jaggedy. How can we do that? Okay, so let's go into the asteroid class. So let's see first of all what we had initially. In our constructor, we passed in the P5 framework just so that we could use that in the asteroid class, and we passed in an X, a Y and an R. So we created a vector with the X and Y. So in other words, we created a position on the screen with the X and Y coordinates, and then the R was just obviously the size of the asteroid. Now that's going to come into play a bit later when we start shooting the asteroids, because on the original game, when you shoot an asteroid, that asteroid destroys, but it creates two new asteroids of a smaller size, and then they exist in the game. So we do need to keep track of the radius and deal with that as and when we come to it, but we'll have to address that later on. But we definitely need to set the radius of the asteroid. And then we have this thing called velocity. Now you may remember from the last video that the X and Y in the create vector, this line here, gives us the position of the asteroid on the screen. But we need to know which direction and at what rate the asteroid is moving. So we have a velocity, and the velocity, every time the page is loaded, the velocity is added to the asteroid's current position, and that will move it in a direction for an amount, and then the screen is redrawn and the asteroid is shown in the new position. So this velocity effectively is keeping a track of the difference between frame draws as to how much the asteroid appears to be moving. So it obviously varies from asteroid to asteroid, and if you look on our demo at the minute, some of these, this one here for example is moving quite slow, whereas this one here is moving a bit faster. This one looks like it's slightly faster again. So you can see they're all at varying speeds. So that's where we are with the asteroid, but what can we do to make it more, give the appearance of the original asteroid? Well, if you do a search for asteroid, if we just go to asteroids game, let's just look at some of the images here, and you'll see that the asteroids have this sort of, they are round in a general sort of sense, but you can see they've got like an abstract kind of border to it. So that's what we need to try and recreate. And what we're going to do, I'll just show you this briefly on my drawing here. The way we're going to do this is, at the minute, forgive my circles as well. Okay, no, it's about. So at the minute we have a circle for our asteroid, and that's simply done with one command. If you remember in the show, command of our asteroid class, we have this P5 ellipse, and it simply sets at a certain point an x or y, and then the width, the full width and height of the asteroid, which is the radius multiplied by 2, and we have our circle on the screen. But what we can also do, we can change how we draw the ellipse. This in effect is sort of a convenience method. What we can actually do is draw the ellipse, or the circle in this case, on a point-by-point basis. So that's what we're going to do first. We're going to redraw the circle, but in a more complex way, so that we can do things with the edges to make them more of a jaggedy. So what we'll do, we'll leave the ellipse there, but we'll just take it down in its brightness for the line. So let's just call it, let's say 50 for the line. Now that should dim them right down now. Where are we? Let's go back to our game, and there we go. See, so that's really dimmed it down. So we'll just leave it as an outline for when we draw the new thing. So how do we draw the jaggedy? Well, what we need to do is we need to think about the number of points that make up a circle, because if you go back to your geometry days, a circle is in effect a polygon. It's a shape with many, many sides. An infinite number of sides if you were being technically accurate, but obviously we can't recreate something with an infinite number of sides, so we have to sort of pull out a reasonable amount of points around the edge of a circle, and then what we do is we just simply draw a line between each of them points, and that gives us our complicated made circle. Okay, so that's what we need. So let's give ourselves a number of points just for argument's sake. So for now, if we just simply say this dot points equals, let's go with 10 just for argument's sake. We can change that easily enough a bit later on. Okay, so now what we need to do is when we construct the asteroid, we need to set so that every time it needs to be stored in the asteroid class how the asteroid is going to render. It can't change every time it draws, otherwise you'd have this like massively jaggedy asteroid, and every time the screen rate changes it's a completely different shape asteroid, and that's no good. It needs to be the same shape each time the screen draws, so we need to store where this line is being drawn for the asteroid. So how can we do that? Well, what we can do is we can create an array. Now an array is just a collection of individuals that we can run through and like what we call loop through, and that loop allows us to do things with each items in the array. Okay, so that'll become more clear as we code this out. So let's first of all set let's just call it offset equals array, and let's see, how can we do this? I wonder if I can just directly set offset in a loop. Let's set up a loop. So let O equals 0. So you remember this from last time when we did this. We initialize a variable to the value of 0. Then while it remains less than the number of points on the circle, so while it remains less than this dot points, or in this case while it remains less than 10, every time it loops we add 1 to it. Remember the plus symbol, the increment? So each time it goes through the loop it adds 1 to it. So the first time we go through the loop, O is going to equal 0. If it's successful and it comes to the next time round the loop, we're going to add 1 to it, so then O becomes 1. And so each time we do the loop, O is a different value and can be treated differently. Now in this instance, all we're going to do, if I just grab this offset from here, and all we're going to do is say this offset O, which is the point in the array, so it could be 0, it could be 1, it could be 2. So this offset O, depending on the loop, equals something. So then at the end of this we'll have an array with 10 elements, and each of them elements will equal something. Okay, so for now all I'm going to say is 0, just for simplicity's sake. Okay, so now that we've set this to a offset of 0 for each one, we can go down to the show, and we'll leave that ellipse in there for now, and no, I'll put a comment in. What we're going to do is now do the more complex circle generation. So let's see, we just need to change the Let's change the fill and the stroke weight. So we can copy these. Actually, no, the fill can stay the same, but the stroke we'll put to 255, which is bright white, just a white light. We'll leave the stroke weight at 1. So in actual fact, all we've done is change the stroke weight, so that's absolutely fine. So now, here's where we make the complex ellipse or circle. So what we need to do is call a function called p5.begin shape. Now what this means is we're now going to begin a series of points that we want to render on the screen, and then we'll close off this shape, and then we can join the lines together and finish this as a circle. So we can go with p5 begin shape. So we're going to close this with p5 dot end shape. Okay, so now in here we can start running the loop that we had earlier. So we can take these points here. In fact, I tell you what, let's just copy and paste that in there. So we're just going to loop over this point again in the same way as we did earlier, except for this one, rather than setting the offset, we're going to use the offset. So now this next line, there's a lot going on. Don't worry, we're going to explain it as we do it. But let's just type it out first of all. Let means we're going to assign a value to a variable that we can then use in the code. Okay. So we need to find the angle. So let me just explain what's going to happen here. I'll tell you what, let me just finish this off. Let angle equals p5 dot map what are we going to call? We need to reference O, which is 0 to this dot points 0 p5 dot 2 pi. Okay, so I'm going to explain this all out, so don't worry about it. So let's go to the iPad. Okay, so we have our middle point here, and what we need to work out, we've set 10 points on the screen, so we effectively start at the top. I don't think it does start at the top, but we'll start at the top, and we go, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's our 10 points that we're going to plot on the that we've got from our code, which is this 10 here. And within these 10 points, we've looped over from 0 to this number of points, and we've simply set the offset at the minute as 0, and that's fine. So what we need to do is we need to do a conversion called, I think it's called polar to Cartesian conversion. Again, it sounds complex, but what that means is, if we were to draw this isn't really great as a drawing, but if we were to draw this on a graph, so let's say we drew a line down there, line down there, line down there, line down there, line down there. So assume that middle point is on that line there. So at the minute, we would have, if up was 0 degrees here, then each one of these would represent an angle. So you'd have an angle in there and an angle in there. And then the radius would be the distance. Now from any given point, if you have an angle and a distance, then you will arrive at a point, because you'll travel a distance in a certain direction will get you to a point. So that's polar coordinates. But what we want is Cartesian coordinates, which is effectively on an XY grid. So we want to know if that's the Y line. So we'll have another Y line there, another Y line there. So we want to know how far along the Y line, which is how far along the X line, and how far up the Y line that these particular points are. So if this was 0, 0 here, then how much x is this point and how much y is this point? So what we need to do is we need to do a little bit of trigonometry. So the first thing we need to do is we need to get the angle. We need to get the angle. Let me see, where have I done that? Just let me. Okay. So the angle is we're taking O. Now remember, this is looping over 10 times, and every time we take the value of O, which is either 0 through to 9. That's the 10 values. And we know that each time it's going to be somewhere between 0 and 9. But what we need to do is convert it to an angle. Now, ordinarily, we would deal with angles in a circle as 0 to 360 degrees. Computers, when it comes to rendering graphics, tend to work in a different way called radians, and they measure degrees differently just to make it easier for them. But effectively, a whole circle is a constant variable called 2 pi. So a half circle will be pi, a quarter circle will be pi over 2, and so on and so on. So you'll probably see that as we go through the code. So P5 just basically means a whole circle. So in a sense, what we're saying is take the value of the point in the array that we're looking at, and proportionally, based on 0 to 9, which is the figures we have, divide that up so that it's proportional to the full sort of rotation of a circle. So in other words, in our display, 0 would be here, 0.1 would be here, and this would be the angle for 0.1. 0.2 would be here, and this would be the angle for 0.2. This would be the angle for 0.3, 0.4, 0.5, and so on. So that will have an array of angles. Because we already have the distance, we already have the radius from the point, we just need to know at what angle now to draw that point on the circumference of the circle. So, let's see, where are we? So we have the angle. So now that we have the angle, we now need to do the Cartesian. We need to work out how far along this is going to be and how far up this is going to be. So what we're going to do is declare 2 more variables, which we'll call x for along the left and right, and y for the up down. So here we're going to go let x equals, now this is going to take us back to trigonometry, so I had to brush up on this in order to get this to work. So let x equals, so then we're going to say this dot radius, okay, so that's our asteroid radius, and we need to add, we're just going to do this for now, we're just going to do this dot radius multiplied by the cosine, which is p5.cos of the angle. Okay, so again, if you've done your trigonometry, you may have come across this, but basically this gives us the distance along is you take the angle and the radius, and we can work out the distance along on that graph. That's what this formula gives us. Equally now, we can get the height with a similar one. So let's get the height. Let y equals this dot radius multiplied by p5, and now we're going to use the sine method, and again multiply that by angle. So now we have our x and our y. So now what we can do is simply just plot a point where that x and y is. So let's see how that looks. What I'm going to do, I'm just going to knock out the original ellipse. Oh no, because I've put it as a faint one, haven't I? So I'll leave that in. So what we can just simply do now is plot a point. Now we could use point, but because we're inside this begin shape, we need to use this thing called vertex. So simply go p5 xy, and that now should plot that point at x and y for each of the 10 items in the loop as it goes around the circle. Let's see how this works out. So let's just let's bring this back up, and if we save this, Oh, right, we have an error. Okay. So in original, we have cannot set property 0 of undefined in new asteroid. Okay, cannot set property 0 of undefined. So what have we done here? This, do we have to set this offset? Yeah, so remember we said earlier we might have to declare the array first. I think actually, can I just put it here? Is that going to work? Yeah, okay, there we go. Oh, right, okay, so what we appear to have is a quarter of a polygon up in the top corner. Okay, so what's happened is we haven't taken into account the relative position of the current asteroid. So it's just gone to the top left. We know top left, which way are you looking at this? Top left is 0, 0 by default, so it's just shot up there. So what we need to do is make it relative to the current asteroid position. So how do we do that? Well, you may remember from was it from the here where we used the translate function? Did we use translate? Oh yeah, have we not used the translate function yet? No. Okay. All right. Well, okay. So we're going to use something that I'll call translate. And what translate does it basically is like a shortcut to say, well, translate to a certain point, and from that point on, that becomes our new origin, our new 0, 0, x, y. So it's no longer the top corner, whichever way it is. So it makes it easier for us to then think about coding up the x and y's that we need to do. So what we can do is, have we used push and pop? Is that something else we've not used yet either? Hey, okay, so there's a couple more new things we're going to learn here. So first of all, each asteroid is relative to its own space. It has nothing to do with any of the other asteroids that are being shown on the screen. So because of that, anytime we try and do a translate, we have to do the translate in isolation for that asteroid. Because if we translate to that asteroid and then we try and draw the other asteroids, they're all going to be relative to that one, and that's not how it works. Each asteroid is totally independent from anything else on the screen for that matter. So in order to do that, in order to isolate the code when we use the translate function, the first thing we need to do is wrap this whole bit of code in a push and a pop. So this is dead easy. It's just p5.push at the beginning and then p5.pop at the end. And all that basically means is, I suppose it means push it into a container, do whatever you want in the container, pop it back out, back to its original state. So it doesn't contain any translations that we've applied to it within that container, so that by the time the next asteroid comes along, it's starting afresh again with its own set of parameters. There's nothing lingering from the previous render, the previous asteroid. So what we need to do now inside here is, so we've declared this ellipse at position X and position Y, whereas this we didn't. We just simply did it literally from a base point of 0, 0. We didn't define any point like we did in here. So if we're going to put a translate in, we need to sort of take it out of here as well and treat this the same way as we're treating this here. I know this is all sounding a bit complex. It will become obvious. So what we'll do, again, a very simple function, p5 translate, and we're just simply saying how far do we want to move it in the x along the left and right, and how far in the y up and down to set our new point of origin. So the easiest thing to do here is just use what we use for the ellipse, which is the current positions x and y. So let's copy that and put that in there. Now because we've translated to that, we no longer have to draw this ellipse to these positions, because now the ellipse is effectively at 0, 0, because we've translated to the current asteroid position. And the ellipse is always based on the point of the center of the asteroid, so it's always going to be 0, 0. I hope that makes sense. I know we've just done quite a bit of complicated stuff there, but this just means for now, for the inside this push pop, we've done this translate to the asteroid position. So anything we draw now is relative to the asteroid position. So the ellipse, the center of the ellipse, is relative to the translation here, which means it's 0, 0, because that's where we want to draw the ellipse. So hopefully that makes sense. We've already done this relative to 0 because we didn't apply any kind of relative position to it, so that's now at 0 as well. So let's see how this turns out. Let's press save. And there we are. So we've now got our 10-sided polygons overlapping the circles. So this is excellent. This shows that our complex circle, as it were, is now being rendered. But a couple of things here. Number one, 10 is obviously not going to be enough, certainly not for these size asteroids. Oh, actually, no, maybe, because they're not going to be circles. No, maybe they will. We'll leave them as they are for now. But what we do need to do is close off this circle here. And the way to do that is when we do end shape, we just pass in a constant. I've forgotten what the constant is. P5 close. So now when we save that, there we go. So now all these asteroids are being rendered with their 10-point circumference, but we've still got the original faint circle that was there originally, and that will come into play in a moment when we start fiddling with this new one. Now, so what we've managed to do is create a 10-point circle. So is that a decigon? Is it a decagon? I don't know. So what we need to do is now add the we need to change this offset. So first of all, if we add the offset here, nothing's going to change because the offset for every point is 0. But let's add it anyway so that we've got it ready. So what we need to do is inside here, rather than just simply say this radius, we're going to say this radius and then wrap that in brackets because we need to add before we multiply, and obviously in mathematics multiply takes priority. So we need to add to this dot offset and then the current offset of this array, which is O. So we're going to add the offset, and then we'll do the same with this one here. So let's wrap this in a parenthesis first of all, and then do plus this dot offset O. So basically what we're saying is the y and the x, if you look on here, this is a point here where the y and x is being rendered. We're going to offset it either so much in this direction and the same amount in this direction. So for now, if we save this, nothing's going to change. We're still going to get our 10-sided because remember we set it all to 0. So now here's the key. If we change this from 0 to a random number, then these points should vary as they go round. So let me just check my code. Okay, so P5 has a random method, and inside that random method we can put two numbers in, a from and a to. So I'm thinking we've got a radius here of what did we pass the radius in as? Yes, 50. Okay. So I'm going to hard code this for now, but I think again when we refine this a bit later we're going to have to come back to this, but we'll just hard code it for now for argument's sake. But I think if we do a range of -10 to +10, and just let's see how that works, we can always change it later. So from -10 to 10 is the offset. Now watch what happens to these polygons now when I save this code. Hey, so there we go. So let's have a look here. So first thing you'll notice is now we can see that faint circle in the background again. In fact, let me just lighten that up a touch. Let's take it to 100. Well, I'll tell you what. Let's give it a colour actually. There we go. So we'll give it a blue. So we can see the faint circle there. In fact, if we put that, no, we'll leave it behind for now. But you can see the circle. So the asteroid, each point has been moved by a certain amount in the X and Y direction from where it should have been rendered. And what that's left us with is this more jagged effect. We could maybe 10, maybe we could go bigger than 10. Where do we set that? So let's say maybe 20. See how that looks. Oh, okay. So some interesting shapes there. That could work. Quite like that. Okay, let's leave it at that for now because we've got something more resembling asteroids. If I just take out the circle altogether, just to give you a view about how they're going to look. Oh yeah, they look great. That is really cool. I'm going to leave the circle in for now though because I need to do something later to do with collision, and I just want the circle to be there to explain that. But that's cool. That's it. We've got our asteroids there in a nice shape. So next thing I want to do is see if we can get a ship in here. So let me just see if I've got the controls for a ship. I think, yeah, I've been thinking about this. In the traditional game of Asteroids, what will happen is, can we go to videos on this? Playing YouTube on YouTube. So let's just, you'll notice that we have the ship and it rotates, and then you press your up button to push it in the direction that you're currently facing, and that's how the maneuvering of the asteroid or of the ship works. We're not going to do that. Let's just be straight here. We're not going to do that. To be honest, it would be nice to replicate that for the retro original game we're setting up. But to be honest, it was difficult trying to get that to work the way I wanted it to work, and in reality, we're not going to use it in the multiplayer game anyway. There's a much more popular way of moving characters and ships and objects in multiplayer games now. That's much more what people are familiar with, and I think to try and build the retro version just for the sake of building it, I don't know, maybe that's not a good idea, but I'm not going to build it because I think we could better off spend our time doing other things. So what we're going to do is build the movement system based on a sort of a current game, which is maybe where you use your arrow keys, or your, is it D for left and right and WS for up and down, and then that moves you around the screen, and then to point, you're simply going to point in the direction of where your mouse is. Okay, so that's what we're going to try and implement now. So let's see, let's go back to the code here. Oh, I've just clicked the wrong thing. Let me just close this down a second. Okay. So let's do this. So let's create now a ship class. So in our classes folder, new file, and we'll call this ship.js. Okay, so how do we set up our asteroid class? Export default class asteroid. Let's just copy that line. Let's go to our ship class. Call it ship. Let's close off the class. So what did we do? We set the variables local to the class, and then we ran a constructor. Let's just copy this for now. So that's the local variables and the constructor. Go to the ship class. Let's paste them in there. Right. Because we're going to use some of these anyway, really. The radius we're not. Oh yes, we are. We're just not going to set it from outside. But we are going to set the XY. And yeah, we also, for this particular one, if we go back to original, do you remember we had two P5 variables here that we had? We had the one with the capital P and the one with the small p, and up to now we've only used the one with the small p, so that's the only one we've passed in. But for our ship, we need to pass in the capital P, and we'll explain that a little bit later on when we get to it. So we've got P5, capital P5, and we're going to set the X and Y of the ship so that it can be drawn at that point. So let's, similar to the asteroids, we set a position. So we have a position, P5. We have a We don't have a velocity. Do we have a velocity? No. No, not at this point. We do have one later, but it's passed into another method a bit later on, so we'll take that out. Radius we don't. Did I say we have a radius? Oh yeah, we do. Yeah, I'll just make a ship of maybe radius, I don't know, 20 or something, I don't know. We'll alter that later. So we're passing in an X and Y to the constructor, and what we're going to do is create a position. We've got our radius, so we don't need to set that, we've already set that here. The velocity, I'm going to come back to later. We don't have the points, and we certainly don't loop over any points. So for the constructor, we have a position. So what we can also do here is take out the offset. We don't need that. Okay, so we have our ship class. We construct it with a position. So let's give it a show method. How did we do that? Just okay. Let's copy the one we did in the asteroid. So ship show. Let's close that off. Pass in the P5 library. And okay, so let's set some parameters here. Let's think about this actually. Where are we? Right. So we want to draw a ship. Now, in the original asteroid, as you're probably aware, it's sort of a triangle shape like that, and so it shoots off in that direction, whichever way it's pointing. So the middle of the ship is going to be sort of somewhere around there. So what we need to do is work out the 3 points here, 1, 2, 3, relative to this point here. Now it just so happens that the P5 library has a method called triangle, where we pass in the XY coordinates of each of the 3 points of the triangle. So for the show methods here, we can simply put P5 dot triangle, and then we just put 3 sets of pairs of XY coordinates relative to the center of the triangle. Now here's the thing, when we did the asteroid earlier, when we did it relative, remember we had to use the method translate, P5 translate, and then what that did was everything from then on was relative to that position that we'd set. This position effectively became the 0, 0 while it was inside this push pop loop, if you remember that just earlier on. So we can do something similar again. We can take the position of the ship, and let's put that in first. Let's do P5 translate. So we're now doing everything relative to the middle of the ship. Now, something we need in the ship that we didn't have in the asteroid, I should have put that in here earlier actually, is a heading. And to start with, we'll just put it to 0, but the heading is basically the direction that the ship is pointing in. Okay, so we'll just set it to 0 for now. I think what happens is the heading is going to be based on, we said earlier, in the modern style of moving a character around, it's going to be relative to where the mouse is on the screen. So so if the ship was here and my mouse is here, then the ship will be pointing in this direction. So that's how we determine the heading. So when we first create the ship, we'll just set it to 0 first, and then it'll pick up the mouse position in a moment. So now that we've done a translate, we can do the triangle. So we want, we want to come, remember that 0 is in that direction for Y and that direction for X and that for Y. So from this point, the first point, which we'll do here, it's on the same X point, so that's fine. So we can simply say 0 for our first point, but it goes minus on the Y axis, and it goes by an amount, which we can use the radius for that. So this dot rate fact, radius, it's not the ideal term for this. But imagine like this was a circle around that point, I suppose. And the ship doesn't necessarily have to be a triangle in the multiplayer game, so we'll call it radius for now, but you know what we mean when we say that. So that's the first point. The second point can be, well, we'll go clockwise, so we'll come to this point here. So this point, it's not quite that distance, is it? It's sort of it's a thinner triangle, if I remember rightly. So this could be like, this way could be half the radius, and say this way could be the radius. That might work, possibly. So the x is going to be half the radius in the positive direction. So let's say this dot radius divided by 2, and then we said in the positive direction of y coming down, it's just a radius. So this dot radius, and then for the last point, it's the same y position, but the x is in the negative direction, half the radius. So we need to see minus this dot radius divided by 2, and then the y position is the same, which is just this dot radius. Okay, so let's see what that gives us. I have no idea. So at the minute, we're not getting anything. Okay. Let's just put a stroke on there. P5 dot stroke. Let's make it red, just for argument's sake. You may notice that sometimes in the stroke and the fill I use a single colour, and sometimes I use 3 elements. If it's a single colour, so for example this, then we just do a grayscale from black to white. Black will be 0, white will be 255. We'll call them. We'll discuss the colour ranges maybe in more detail at another time. But basically, for each colour combination, or for each colour gradient, there's 256 sort of possible gradients from 0 to 255. So if you just put one parameter in, then it just thinks it's a grey, somewhere between 0 and 255. Whereas if you put 3 in, then it treats each of these as a different colour component, which will be red, green, and blue. So this basically means full red, no green, no blue. So hopefully this will give us a red outlined ship if I save that. Again, I'm not seeing anything, so we obviously haven't done everything right yet. So what else? What else haven't we done? Stroke. Do we need to do a stroke weight? Maybe P5 dot stroke weight. Let's say 1. A width of 1. Do we get anything? No. No. So we're still not getting anything here. This is a little bit of concern, because I thought we would eventually be getting to see something. Let me just check my code. Oh, we haven't even done anything with this ship class. We've created the class, but we haven't included it in the actual code. Do you remember we created an array of asteroids and created a new asteroid that many times? We need to do the same with the ship, but obviously we only need to create the one. So let's do the same as we did with asteroid. Let's import the ship class. IMPORT, we'll refer to it as ship, from at classes. Can't believe I forgot to even import it. Anyway, import ship from classes ship, and then we only need to create one, so we can create that once in the setup here. So let's say put them into asteroids, didn't we? So let's put ship here. Let's just set it to null to start off with. It's not a problem. But then here we can say, where are we? This dot ship equals new ship, and then we have to pass in some parameters here, don't we, in the constructor? So P5, the big one, X and Y. So let's see, we've got P5, big P5, and then we want an X and Y. So to start with, we'll just put it in the middle of the screen. So the easiest way to do that is P5 dot width divided by 2. That gives us halfway across the screen, left to right. And then P5 dot height divided by 2. That gives us the top and bottom middle of the screen. So now we've drawn the asteroids here. Now what we need to do is draw the ship. So this dot ship dot show. Will this work? Cannot read property translate of undefined in ship. Okay, that's cool. So it means it's running the ship thing here. Ah, okay. So so in the show method, where are we? The show method. Ah, yeah, we need to pass in the P5 library like we did before. Ah, ooh, look at that. So this ship show. Actually, I'm going to take this out the constructor. We don't need the big one in the constructor. So let's just take that out for a minute. And where do we declare the ship? Yeah, let's take that out there. Okay. So we now have the small P5, the width in the middle, the height in the middle. Well, the width and height's worked, so let's put it in the middle. Let me just reload this page. Okay, no, that's cleared. It must have cleared up when I fixed the last error. But we have this here, which is most certainly not a triangle. So what's going on here? Let's have a look at the code again. So we're going from. Let me just check my reference here. So we're going from 0 to this radius. So that's going to be. Where's my drawing? So 0 to, which is X is not going to move, but Y it's going to move to minus this radius. Ah, I've pulsed this radius. Remember, going up is minus in Y terms. So let's save that. So hey, look at that, we have our sort of ship. I'm not so sure about the proportions. Let me just take off that divided by 2 again here. Okay, no, that's not really what I want either. So let's just go back to that. But we can certainly get rid of the fill. So P5 dot, well, we can say no fill. Yeah, and we might as well put the stroke back to white. So that just means making it 255 on the single scale. Yeah, excellent. Proportions just don't look quite right. I'm not. Yeah. Okay. Well, no. Suppose they're not. It's not far off, is it? If we can just bring the top down a touch. No. Do you know what? Let's leave it for now. So we have our ship, but it doesn't do anything. So we've got 2 things we need to address. Number 1 is the rotation, and number 2 is the movement. Now, like I said, we're going to adopt a more modern style movement of the up, down, left, right. So let's do that first. Okay, so let's go to the ship class, and we need to set a move, build in a move method, and okay, so what are we going to pass in here? Well, basically we're just going to pass in an X and a Y. In other words, how much is it going to move by, and obviously we need to pass in the P5 library. So let's pass in P5 and then an X and a Y. Straightforward. So what we're going to do, now we talked earlier about possibly putting a velocity in here, but the velocity is just going to be a local variable for the move method here. So we can simply declare that. with let velocity equals, and then we'll do what we did in the constructor, p5 dot create vector, and with the x and y. So that gives us our velocity, which is basically an x and y, which is a distance from the current x and y. So that then works out to a direction and a magnitude in that direction. So that gives us a velocity. That's how much time it will travel during this frame run. So all we have to do now is take our current position and add the velocity. P5 allows us to do it in this way. The position will now be reflected by the change, but we've also got to call the move method. How do we do that? Well, if we go back into original, what we need to do here is we need to capture now keyboard commands, so input on the keyboard. So the way we do that is we're gonna call a method every time the frame is every time draw is run. So in our set of methods in the original file now, we need to capture the key press. So what we're going to do is create a method called capture key press. We can call this whatever we want. This is just a method that I'm using, and I think in there all we have to do is pass in the P5 library, and then all we're checking here is whether a key has been pressed, and if so, which one. Now eventually we're going to go to the ASDW keys to do this, but just to make this easy for now, we're just going to use the arrows because there's an easier method naming convention for the arrows to move up, down, left, right. So what we're going to do is say if p5 dot key is down. So key is down is a method in the p5 library, and then we have a constant which is p5 left underscore arrow. So basically what we're saying is if the key is down and it happens to be left arrow, then we do something. Now left arrow is going this way is minus on the x-axis. So effectively what we're going to be doing is taking an element, a number away from the x value of the ship. So remember we set up a move method earlier, and all the move method does is take an x and y and adds the value of the x and y to the current position. Now bear in mind that if you add a minus number to a figure, it decreases the number. So to make it go less on the x, all we have to do in here is pass in a minus number into the x value, and that should add a minus number onto the current ship position, which will move it to the left. So let's try that. So we need to go this dot ship dot move. So remember we did P5, and then how much we want to move it to the left. So let's just do -1 for now, and then the y position for the left arrow doesn't change, so we'll just leave that at 0, and we don't want to affect the y position. So that's a capture key press method done, but we need to refer to this every time the draw method runs. So inside our draw method we need to call, so every time, remember this draw method's called every frame, so we need to check this every time to see if a key is pressed. So we just call that method, capture key press, and remember we just have to pass in the P5 library to that. So that's it, no errors, that's fine. So now what should happen is when we press the left arrow, hopefully the ship will move to the left. Let's try it. Hey, look at that, we have a left moving ship. Not particularly quick, and none of the other keys work at the minute, but the left works. So we know this method works. So what we can do now is do the same for the other three keys, directional keys. So we can just copy these lines. If you're in VS Code, I think Shift Alt and down. Yeah, we can copy that 3 more down. If not, just copy and paste the lines. So we want to do now right arrow, up arrow, and down arrow. Right, so the right arrow is going that way, which is from here, it's going this way, which is plus along the x-axis. So basically we just need to make that a plus, and the y-axis isn't affected. The up arrow isn't affected by the x-axis, so that can be 0. On the y-axis, going up is less. Remember 0 is in the top left, so we can do that to -1. And then that means that if you want to go down on the y-axis, it's +1. Let's save that. Let's try our keys and check that. Yay! The 4 keys work, and if I hold 2 in combo, I can go in that direction. That is more of a common way to see these kinds of games being maneuvered about, where you can move the ship in that direction. To be honest, it does seem a bit slow though. I'm just wondering whether perhaps we can increase that. We'll have a mess with the velocity and magnitudes a bit later, but we have it working, which is great. So the next thing we need to do is the rotation, and we said we want this to point in the direction of the mouse. So first of all, what we need to do is make sure we've got the mouse position here. So let's go back to the ship. Now, for this original version, I'm just going to grab the mouse parameters directly in this class. I don't know if that's the best way to do this going forward, but I'm going to do it here for now. We'll just grab the mouse position. So this is easy to do. What we can do is P5 has some variables that show you the mouse position. So let me show you this. The thing that's of concern to me though is how it relates to the translate, because the translate is relative to the ship, and we don't really want anything to do with the mouse inside the translate. Although it is a global variable, it might not be affected by it. Let's just try this. So P5 dot ellipse. So let's draw an ellipse where the mouse is. So the way we get the mouse is P5 dot mouse X, P5 dot mouse Y, and we'll make it a radius of 10, for example. So now if so yeah, it's moving at the same rate as my mouse, but it's obviously not in the right position. In fact, looking at that, it looks like it's translated to halfway in the screen. Okay, so let's just work this out. We have translated to the position of the ship here. So then this mouse X, mouse Y is relative to the ship. It's obviously been affected by it. So if we were to move this outside of the translate, look at that. Now that works. Ooh, yeah, that's quite cool. So that works. The circle is being drawn at the right place on the screen, so it's not affected by the translate. Okay, so we know that mouse X and mouse Y equal where the mouse currently is. We translate the position of the ship to 0 we translate 0, 0 to the position of the ship. We then need to get a heading. Now, the way to do this, if we go to reference here on the P5 reference, there is a function called atan2, and look at that. No matter where I put my mouse, that bar will follow, as in the direction from it to my mouse. So that's pretty much what I want, because I want my ship to point in the direction of where my mouse is. So it uses this function called atan2. It takes the mouse y, which is what we just used, and takes away the height divided by 2, because it was centered to the middle of the screen here with translate. Now that's interesting. It translated it to the middle of the box that it's in, and then it uses the mouse y minus the height divided by 2, which is what I put in there. So let's see if that works here. So let's put the ellipse back after the translate. So translate this position x, this position y. So we said that the so we said that the angle, so let's set an angle here. Let angle equals, let's just copy this here. So we need to put P5 before this, remembered, because of the way we've instantiated all of this. So we need to put P5 in front of height. We need to put it in front of mouse X, and we need to put it in front of width. Okay. So let angle equals, we've copied that. So then what does it do? We then rotate by that angle. So, okay, let's try that. We'll put a semicolon in there, don't need that. So P5 dot rotate angle. Then we draw the triangle. I hope you're following along with this, because I'm hoping this works. Let's just do that again. We've translated to the position on the screen where the ship is. I'm not sure how that's going to work with the mouse. It looked like that worked, but I've put it back to what it was when it didn't. So, because I'm not sure how that's going to interact correctly, but we'll come back to that in a sec. We've set an angle which uses this atan2, which follows the direction of the mouse. We've rotated everything we're going to use in this function by that angle, and then we've set the stroke, no fill, set a stroke weight to 1, and then we draw the triangle. Let's see what that does here. Do I need to save this? Let's save that. Of course, P8 is a P5 method. Let's save that. Okay. Oh, look at that! It's pointing in another. Look at that! And although this circle is drawing down the bottom right of the screen, the ship is reacting correctly to where the mouse is, although it's just pointing in a quarter turn in the wrong direction. But if I come over here, it's pointing, the side's pointing to it, the same side is pointing to it there, it's pointing to it there, pointing to it there. Way, check that. So let's get rid of that ellipse. So it looks like we need to rotate the ship by a set amount plus the rotation that our mouse direction is giving it. So you remember earlier we talked about pi and 2 pi and the way that circles use this radians method, or the graphics engine use a radians method rather than degrees. So a quarter turn in this instance is pi divided by 2. Remember, a full circle is 2 pi, half a circle is pi, quarter circle is pi divided by 2. So what we can do when we do the rotate is we can simply do we add or take away? Let's add it to start with. P5 dot the constant pi divided by 2, which is basically quarter circle. Let's save that. Oh, right, okay, we went the right way. Let's just get rid of that because we know that's fine. And look at that, our ship is pointing to the mouse. Now let's combine that with our movement. Now that hasn't worked, has it? Now look at that. Now that's about the center of the screen where my mouse is. So when the ship was at the center of the screen, it picked up correct, but as soon as the ship moved away, it's still referring its direction relative to where my mouse is to the center of the screen, not to the position of the ship. Okay, so that's not quite right. Okay, I'm back, and yeah, worked out what that problem was. So we've worked out that with this, when the ship is in the middle of the screen, it's perfect. It works fine. If it was where my mouse is now, but obviously it's moved, but it's still the mouse, or it's still reacted to the mouse as if it's still there. So what that tells us is that the formula here to get the angle must have to include, it's irrelevant to the screen, but has to include the position of the ship in order for it to make sense. So rather than have this P5 height divided by 2, we're simply going to say the ship's position on the y-axis, and then again, rather than having P width divided by 2, we're just simply going to take away the ship's x position along the left right. So let's see how that works now. So everything's fine. If I move it, and there we go, you notice how it's still following the mouse regardless of where it moves on the screen. So yay, we have now our moving ship that responds to the mouse position. We have our asteroids that are looking a lot more like asteroids. This is probably a good time to end this video. I was hoping to get the shots in as well, but this has taken a bit of time. So what we'll do is, in the next video, we'll look at getting the shots from the ship in, and then obviously we can also look at things like collision detection, how we're going to manage when an asteroid hits the ship, like now, or also when the ship hits an asteroid and it goes through the process of splitting up into smaller asteroids. So we'll do that as well. But that's it for now on this video. Hope you've enjoyed it. Please like. If you like what I'm teaching here, please subscribe. And obviously, if you think of anyone you know who's also maybe interested in following this, please send them a link to my channel. Thank you very much.